There we go. So go ahead, Ron.
All right, everybody. Good morning. Hello, welcome aboard. We're live on the 26th of April. It's our weekly SBAU podcast every Monday morning, 11 to noon, from our little dens and, I guess, mail caves, online, on Zoom. And we talk space stuff every month, 4 times a month. This is program number 9, series 1, I'm calling 2021. We get in new launches and discoveries, rovers on Mars, and little wild helicopters, comets, asteroids, NASA, all the private space launchers around the world. Man's going into space, everybody, and we're watching it happen. So welcome aboard. It's the Santa Barbara Astronomical Unit, your longtime South Coast Telescope and Astronomy Club. Love to have you join us because I eat this stuff up. My name's Baron Ron Herron. Proud to be VP of SBAU, which not only meets on the first Friday of the month when there's not a pandemic, Farrand Hall at Santa Barbara's Museum of Natural History, which endorses and supports us. And we miss them, we miss you, we miss everybody. When we're not in the pandemic, though, the museum will be there. They're open now, and incidentally, they've got the dinosaurs back. So we'll invite you to join us, SBAU.org. Let's talk to the gang and meet the incredible, I call them the brain trust for the astronomical unit. 3 times our president, Jerry Wilson. Good morning, sir.
Morning. Good morning.
You and Pat doing all right? Still behind closed doors?
We're fine. Well, we've all got double jabs, so we're not so much behind closed doors anymore.
That's true. We got family and we don't have our masks on at the moment. We're still wearing them in public. And just like Chuck McPartland, one of the best outreach coordinators in the world, you and your Pat, we are proud not to be part of the 22% of the public that is refusing to take the vaccine. That's going to be interesting. Tom Totten is our webmaster and technical wizard, former president up there in the left corner. Joining us at the bottom of the screen for now, Tom Whittemore, former Westmont College science instructor, and I understand a damn good one, and that's got to stop. The editor of our SBAU monthly newsletter, which I guess features another article, does it not, by our president, Tom?
Right. Jerry did send me one, and I'm putting the thing together for Chuck to review.
And we really shouldn't forget people like Colin Taylor, our treasurer, who was so awesome. Was always there. Carol Ann Moore, is that her name?
Yeah.
Secretary. And who am I forgetting? Oh, there's a whole
Art
bunch.
Harris. Art Harris equipment.
The merch manager.
Art's doing okay. He's hanging in there.
Yeah.
Edgar Ocampo is back from the Philippines. He got out of there somehow, or is he still over there?
Oh no, he's been home a long time.
Yeah.
Or here a long time.
Well, there's lots to talk about. And Tom, we're on YouTube as well, right?
Merch manager.
Okay.
Yes, we're live on YouTube.
Any
Looking
estimation when you think we'll be back in Farrand Hall on Fridays? Maybe the fall, maybe summer?
2022.
2022. All right. Well, I love this technology. This is awesome. If you want to leave a comment or have a question, occasionally Tim, our incredible, what is our man from the telescope workshop, Crawford. Ooh, look what's that on the screen. That's not Perseverance, though, is it?
No,
You're wrong.
That's
the Chinese rover, which has not landed yet. It will land shortly.
Oh, that's the Chinese on the far side of the moon.
Yeah.
Mid-May. No, this is the one on Mars, Ron.
Your side. It's on Mars.
Oh, on Mars. They're coming on strong. So this is landed or it hasn't landed?
No, this one is going to land on mid-2021 is the only thing they've committed to. So probably about June.
Actually, mid-May they're saying now.
Oh, May? Okay.
Yeah.
Zhurong, I don't pronounce Chinese well, is the name of the lander and is the rover. And Tianwen-1 is the orbiter. And this thing is still attached to the orbiter.
So it's orbiting Mars.
And then it's going to it's going to release this as a lander, and then it's going to go through a landing process. I don't know the landing process. I don't know if it mimics the US NASA one or not, but it's designed to have a life of 3 Martian months, which is equivalent to 92 Earth days. But the US rovers have exceeded that by mucho years. And I assume that the Chinese one will last a long time too.
Do any of you gentlemen know how much less electricity is generated that far away with those solar
Yeah,
panels?
sunlight's roughly half the density it is here at Earth.
Oh, is that right?
Yeah.
And then they didn't learn.
Area.
They didn't learn from our problems with Curiosity or what the one that dusted over due to the
No,
Martian.
They probably did, but I don't see any little whisk brooms up there.
Yeah.
So, they're just gonna, it lasts for a long time. Ours lasted years with just solar panels. Of course, our current rover has a nuclear reactor on board, one of those thermoelectric devices.
Wasn't there a time when they wouldn't launch those for fear? Well, of course, from Canaveral, it goes into the ocean. I guess it's not as
There are certain
dangerous.
types of reactors that they had a policy of not launching because of danger of spill if the rocket blew up. But these are like, these aren't that kind of reactor. These are like an isotope source in a hospital that gets a large sheet of metal hot, and then it says a temperature gradient from one end of the metal to the other, and they have little thermocouples mounted all over the different parts of the gradient. And the temperature difference between two parts of the thermocouple generates a voltage through the thermoelectric effect.
Well, I wonder what they want to learn that we haven't already learned. What kind of instruments do they have on?
There is a tremendous amount of new things to explore and find out about. Every
Really?
time we send a different instrument up to Mars, or every time we open up a telescope on Earth to a new wavelength band, we learn all sorts of new surprising things.
But they do have, I made the mistake a second ago, and thank you for correcting me, Chuck. They do also have a rover on the far side of the moon, do they not? Same time right now?
Yes.
But
Yeah.
and we don't. We have no rovers on the moon. We've got a
That's
lot of
correct.
leftover instrument. What's the Perseverance story? We have a picture of that. Oh, there we go. I
The
think.
flight of Ingenuity.
Yeah.
Yeah.
The little drone that could. And it did. It made its third flight yesterday.
On Sunday, yes.
Yeah, it did.
What'd they do different this time?
They flew sideways and they flew about 150 yards one way, and then or 150 feet one way, and then 150 feet back.
Oh, total like a football field in length and flying.
Yeah,
With
except
no
there
cut.
and back. So they came back to the same spot. You can see it went out of the frame there to the right.
Yeah, there it is.
And it took all sorts of pictures of the tracks that the Perseverance has been making over the landscape in a still picture that I sent.
What would your cat like to say about it? Does he have a comment?
I think he just made it. What he wants is out of my room.
Now, this is not like sitting at JPL and with a joystick, is it? Because it's several hours.
Yeah,
In fact, Mars is further away from us right now than the sun is. It's on the other side, isn't it?
mhm.
Yep.
So the computer takes over, or does it change or
Yeah, it has-
monitor?
It has artificial intelligence programs to do its guiding and make most of its route decisions up there in general compliance with general rules from Earth. You can ship new instructions up from Earth to reprogram parts of it, but not in real time, not to get control in real time.
But what's the ultimate objective? To get some great cruising movies?
Just to fly, and they've done it. I mean, they just want to test how easy it is to maneuver and fly.
Okay. So it so far has snapped single shots, sent them back to Perseverance, which beams them back to us, or does it go up to an orbiter? How does that work?
It beams
Wait.
it to Perseverance, and then it beams it up to the Mars Reconnaissance Orbiter, and then it sends it to Earth.
Wow. But we've gotten what we're watching is it a movie or just a sort of like flashcards?
It's a
It's a movie.
That's a movie.
That's what movies are.
Yeah.
Well, 24 frames a second. Can we go that fast? I'm not sure if they even use that with video. Video is a different ball game, I think, isn't it? Than
30
movies?
frames a second usually.
30 frames. Oh my. Wow. Okay. And
The eye has an exposure time of 0.04 seconds.
well, then what is
That brings you to about 25 or 30 frames a second will look like motion to the human eye.
Okay, and it's looked down at the tracks of the rover, and it's looked at its own shadow of the very light little sucker. They're 4 pounds.
Mhm.
With how many revolutions per second or per minute? 3,000?
2,500 or 3,000.
Good Lord. They don't go that fast down here on Earth, do they? The drones at several hundred RPM, I think.
Yeah, like 500 max, I think.
Okay. Did I hear that this whole program is over in May? Did I hear that somewhere? Is that not true?
The flight
For
program.
Ingenuity.
Yeah.
Just for the helicopter. So Percy, the rover, will be on Mars for many, many years, like Curiosity.
Yeah.
Okay, gentlemen. Any last comments? What's your opinion on all of this, Whittemore?
Oh, just it's amazing what they've done. I mean, this is the first time something has flown, and on another world. I mean, it's just pretty neat. Yeah.
I don't suppose any of you are into drone technology and have drones, do you? Tom, that sounds like something you might want to do. Tom,
Sure.
Cotton? Sure, but no way. It's amazing.
Wally chases them.
Yeah.
Wally
Yeah.
chases drones.
Our cat chases the little helicopter I have.
It's going to be interesting to see the direction, what happens with drones, because the fire departments during fires hate them, but the police use them. So somewhere in between there's got to be a balance. Any other comments before we go on to our next biggie?
I don't know. Did we mention that they did produce oxygen on Mars? They produced, I don't know how many liters they did. Was it milliliters
10
or
grams?
liters?
Yeah, they produced enough oxygen for a human being to breathe it for 4 minutes.
So they disconnected the oxygen molecules from the CO2. The C is on its own, the O2, but you can breathe.
Yep.
Well, I
Wow.
think they just cracked one O off of each CO2 and got carbon monoxide and one oxygen atom.
Right. So they made breathable oxygen and lethal levels of carbon monoxide. So
Yeah.
That's not going to be good. I don't suppose there's a carbon monoxide detector on board, or it'd be going off like crazy.
But the Mars Air Pollution Control District is very worried.
Yeah.
That's the bulk of the Martian atmosphere, as thin as it is CO2, right?
Yeah.
Or C, what is monoxide?
CO.
CO, just one of
Mhm.
these. And that's poisonous. We can handle O2. That's strange. Okay,
Yeah.
gentlemen, shall we, where do we want to go? Coat hanger, the follow-up, our incredible, what is that called? Oh, there's the variable star of the week. We want to cover that at some point
well, let's go to that.
in our podcast. Let me read what I wrote down. Corona Borealis. It sounds like the lights, the northern or southern lights.
Well, that's northern. Borealis is northern, and Corona Borealis means northern crown.
Okay, Northern Crown. So it's out in space, and it's yeah, there it is. It's a small constellation between Hercules, Serpens Caput,
Yeah.
and Borealis.
Boetus.
Is that how it's pronounced?
That's how I pronounce it.
Well,
You
that's
gotta
also
remember that when I first got into astronomy, a friend of mine and I were 11 years old, and to learn the constellations, we made flashcards with the star, with the asterism on one side and the name on the other.
right.
We had never heard these things pronounced, and so we just pronounced them our own way. Some of them were fairly close, but a lot of them, if I say them now, people turn and look and stare at me in the night. They think I don't notice, but I do. So don't ask me how to pronounce these things.
Well, there's a couple little dots over the second O, and when I first saw it, I thought Boots Void. It's
You're
also,
supposed to put a slight R sound on the Brutus.
oh, is that right?
Yeah.
You suppose that's Danish or
Oh, it's German.
Polish?
Well, I don't know. It could be Norse. It's Norse, but it's. We learned how to pronounce that in German class.
Okay, well, you went on to tell us, Jerry, in your email that it represents the crown of Princess Ariadne,
Ariadne.
who helped Theseus defeat King Minos, M-I-N-O-S,
This is Minotaur.
Minotaur, a
He had a pet
monster.
Minotaur.
Okay, catching up on my ancient history here. The Alpha Star.
Chuck's our
Magnet.
history myth person.
Okay, so are we watching this? We're just learning about it from Astronomy Magazine.
Well, yeah.
You actually, it's a variable star, so it means it fluctuates. It's a Cepheid variable, right?
It's not a Cepheid. It's a variable, but not a Cepheid.
Okay, well, what's a Cepheid? Give me a definition again. Tom Whittemore, that's your special.
Yeah, it's a pulsating variable star, usually with periods around 120 days or so, but it could be fewer. They're usually yellow giants. Okay. It turns out our North Star Polaris is a Cepheid. Okay.
Really?
Yeah.
But you never know it till watch it with your naked eye.
No, they're monitoring it because lately it's become sort of unstable. They're really watching that, Polaris. Okay.
So what's the
Our
difference?
Corona Borealis isn't a pulsator, so you can see here that its brightness variations are kind of chaotic.
Yes. Yeah.
Is it a part of a binary?
Don't
Does
know.
it have a partner? A gay marriage of two stars?
It could be as it does. They don't know why it varies. They're not entirely sure. But leading theories include that it's an aging star undergoing flashes of helium burning or emerging binary white dwarf system. Either one of those two can be worked into a model that accounts for this irregularity. It's quite strong. It goes over what, 7-8 magnitudes. So as you can see in the brightness chart, the variability chart, there's sort of a constant brightness, and then it dims from those, and it's the dimming that makes it irregular. But there's a steady line across the top that it doesn't get brighter than that. Yeah. So it could be some kind of obscuration.
Hey, Jerry, the Wikipedia says that the star is 90% helium and less than 1% hydrogen.
Yeah.
The majority of the remainder is carbon.
Okay.
Yeah. So it's red. It'll appear red, and it's just doing shell burning.
Shell burning.
Yeah. Hydrogen on the outer envelope is probably shell burning right now. Recently we went through, Betelgeuse having some strange behavior, not as strange as this, but Betelgeuse is doing shell burning. Okay. And it's got, a lot of helium in its core. Okay. So anyway, this is a pretty exotic star. I mean, it's really changing to beat the band. And, 6, by the way, on the magnitude scale is brighter, 14 is dimmer. So it's changing by, like Jerry said, 7 or 8 magnitudes. That's 2.5 to the 7 or 8 power. That's a lot. Yeah. That's a lot. That's a lot of change in brightness.
So our sun, which is a yellow star, and it's about halfway through its burning stage, is burning primarily hydrogen. It's the first stage of a star that's burning, and it will eventually, and it turns that hydrogen into helium, and then eventually it will run out of hydrogen, and then it will start burning helium. And so, but it'll do some compression at first to get the heat of the core up high enough to start hydrogen burning. But at the end of a star's lifetime, what Tom is referring to is shell burning. It'll have different layers. The whole star doesn't convert to a different type of burning at some point all at once. It starts burning helium, in our sun's case, in the core, but it'll still have an outer layer that's burning hydrogen, the remnants of it. It'll still do some of that. After a star gets very old, you have different levels of it inside that are burning different steps on their way toward iron. And that's shell burning. And sometimes there might be some turbulence that reflects a different, it might shift from a dominant illumination or a luminance source to a less bright luminance source as different parts of the star boil up. So it could be changing from its burning habits, you might say.
Yeah, nicely put.
Well, what confuses somebody like me is that down here on oxygen Earth, hydrogen is very volatile, will burn and explode, whereas helium you can breathe in and sound like Mickey Mouse, and yet we're talking fusion. I know, right?
Nuclear fusion, not chemical burning. We're using the term burning to mean nuclear fusion, which is the addition of neutrons to the nucleus.
And then the third element beyond helium is the one that I never hear about until recently. They're on the outlook for the batteries to have lithium, and they find this it's a white metal, right? Lithium number 3 out in the desert.
Very, very light alkaline metal. It reacts violently with, or reacts with air and water, as lithium does. But the burning doesn't proceed up the periodic table. I think the next jump after helium is carbon. And then the carbon decays back to some of these other things that it skipped over. So it can get to be a very complex set of shells and burnings and decays.
Right.
And lithium usually gets destroyed quite easily by any kind of thermonuclear reaction. So it's rare to find it showing up, at least in the spectrum of the star.
But in a typical star, there'll be a layer of thousands of miles of this one element that's turning into the next highest up.
Yes, at a different time, that's true. It's in a state of flux, slow flux, but it's in a state of flux.
I hear a cat.
I got it's a long story.
Well, this is fascinating stuff. I don't know. When you get to lead and gold, that doesn't bring down a star, but iron does, right?
Right.
Okay.
Yeah, right. Element 26.
One last question from your host here about Bootes or Bootes or B-O-O-T-E-S.
Yeah.
That's also a big.
I say Bootes.
Bootes, is that how it's pronounced?
That's how I say it.
Isn't that also a big, huge blank spot in the sky, a huge void that's 300 billion light years across and hardly any galaxies in it? Have you heard of that? You have.
It's in a region where you don't find a ton of galaxies. Chuck probably knows this better. You start to pick up the galaxies, sort of Leo and Gemini, Virgo. I'm sorry, not Gemini, Virgo.
Corona Borealis has some galaxy clusters, but Bootes.
Nah.
I'm
not a real galaxy hunter, but I don't think it's known for it.
There are voids, not apparent voids so much in the sky, but if you start plotting the three-dimensional characteristics of galaxies, then you'll find voids between them. It looks like a series. The universe on its biggest scale looks like a series of bubbles with galaxies clustered along the interface between bubbles.
Yeah.
Why it has that structure is they're speculating it's frozen in from quantum mechanical fluctuations before it did its super fast expansion.
Right. And then the galaxies are lined up in little strings like cobwebs.
Yeah.
Okay. Ours with the local group, we're kind of condensing together. Most of them aren't they? We're getting Magellanic. How can I say that? Magellanic. There you go. And then as Andromeda's coming this way, we're all going to combine into one huge galaxy in a few billion years, aren't we?
Most likely, yeah. The Milky Way is very, what would you say, hungry or aggressive.
Yeah. If I might add a plug here if you guys don't mind, I'll add a plug for Bootes because one of my favorite stars is Arcturus. And lately, the moon is kind of clobbering this part of the sky right now, but I've been really enjoying just with my birding binoculars. They're basically 8x42s, so 8 power, 42 millimeter front end. They get a good amount of light. I've been enjoying Napoleon's hat. So if you take your binoculars and you look up towards Arcturus, bright red star, it's well up by 8:30 now. You will see this inverted tricorn hat. It's called Napoleon's hat. It's really fun. Again, Ron, it's one of those things called an asterism. I know you like a lot. You love asterisms.
Right.
And there are all kinds of them if you've got a small telescope, because there's ones that look like kangaroos and the Eiffel Tower and,
that one's actually up near there too, Chuck, the Eiffel Tower. I think Sue French had a little article on that not too long ago on the Eiffel Tower.
Yeah.
But the only asterisms the public in general knows about are the two dippers, I think. I just learned last week about the coat hanger. Now we have a miniature. Can I read this? It's Vulpecula. Sure. Last week we hunted down the asterism coat hanger. It's, I guess, arranged that way in the sky, similar to Napoleon's hat, it sounds like. So the smaller, fainter, aptly named mini coat hanger is north, let's see, of the Little Dipper in Ursa Minor, which is the Little Bear, and it's between the star in its handle and the cup. And we can see this any night or most nights. It's in our sky,
Yeah,
right?
circumpolar for us.
Yeah,
Can Australia see it?
probably not.
Probably not.
Yeah.
Too far south.
Is that it on the screen?
Yeah.
You're awesome, Totten. I got to tell you,
Pretty good.
I'm not sure if it looks like a coat hanger or not, or where's the coat hanger part?
It's
Yeah,
in
you can see
the
the hook up there. I see it. That's
in the
neat.
red circle.
What are those stars connected, gentlemen? Can you name them?
That's probably the Little
Where?
Ones with the blue lines. Yeah, the bowl of the dipper is up in the upper right, and the handle goes.
Yeah. Okay.
Oh, the Little Dipper. Okay, so we're looking in on the asterism known as the Dipper. Okay, well, that's the coat hanger, Vulpecula.
The mini
Oh.
hanger.
This is the mini coat hanger in Ursa Minor.
Yeah.
Okay, there's two coat hangers up there. The world needs to know these things.
Yeah.
Uh,
And like, I was going to say, as Chuck pointed out last time too, asterisms can be made from stars in different constellations. A real famous one is the Summer Triangle, Altair, Deneb, and Vega.
Mhm.
You suppose the ancients sat down and some guy looked up and decided, you know what, I'm going to make that into a lion.
Yeah.
And he drew it on the paper or on the table and said, look at this. This is his head. They had to have done it. And now we follow it and use it like gospel.
Yeah.
That's the word.
Asterisms are easier to remember in Sagittarius. We don't remember it for its mythological character we see in the sky. We remember it as a teapot,
The teapot.
steam coming out of with a spout.
And different cultures have had different constellations. It's not like the entire world saw the same things in the sky.
Exactly.
Although something like the scorpion or the lion was tended to go across cultural boundaries.
Well,
Right.
Cassie,
I was going to say, didn't the Pacific Islanders look at it like the scorpion as a fish hook, Chuck?
Fish hook of Maui, yeah.
Yeah. Okay.
well, now correct me if I'm wrong, but Cassiopeia has always intrigued me. It's a big wide W, but somehow they make a chair out of that. Is that true?
Yeah. That's the throne of Cassiopeia, the Queen of Ethiopia.
But that's not the constellation. It's something else, isn't it? What is the constellation called?
Cassiopeia.
Cassiopeia.
It's a chair? It's a throne?
No, it's the queen on her throne, but the bright parts of the constellation are the throne.
Yeah.
And
And
they
when
make-
you see it rise in the northeast, it looks like a W. And when you see it set in the northwest, it looks like an M. It's like an M.
And somehow they got a woman sitting on a throne out of 5 stars.
Oh, there's more.
Well, what was important, Ron, was more the stories that they were trying to remember. They weren't
Yeah.
trying to make pictures in the sky. They were trying to use these as mnemonics to remember stories that were important to them.
Yeah.
All right, since you're the man that knows the history, where did most of them come from? Greek culture, Roman, North Africa?
Most of the current set of constellations come to us from the ancient Greeks, and they came to them from Mesopotamia, from the Sumerians and Babylonians.
Oh, okay. They were really down on it, weren't they?
Along with a lot of our mathematics too.
Mhm.
Plus that little device with the gears we were talking about recently.
That origin of that's really unknown, but they found it on a shipwreck off Greece, the Antikytherian device.
Mhm.
Anti-kit. Wow.
But
Anyway.
no, what I was referring to was probably the most important single mathematical discovery of human history. And that was the concept of a zero, which came to us, I believe, from Arabic math.
From India to them, I think.
India, okay.
Yeah.
Well, okay, that's a math question that totally baffles me. It gives us our tens and 20s.
It gives us our place setting number system. And without that kind of number system, scientific work that depends on math becomes extremely difficult to conceptualize.
Yeah.
Yeah,
So,
picture the Roman numeral for the speed of light.
yeah,
Right.
or for pi.
Yeah.
Oh, yeah, right.
Okay.
So the next thing that's really interesting is from our SBAU Facebook site. I think that's put up by Ruben. He runs that. But and I cite that there. But it figures out it looks at the population of stars in the very outer reaches of our galaxy, where it's surrounded by a spherical hollow of stars or spherical structure. And it's stirred by the Magellanic Cloud that moves through this structure, and in the wake of the stars allows them to do a test for, or a mapping of dark matter in our galaxy.
Whoa.
And so the picture that shows there is a still frame that's the observed density of stars in the Milky Way halo. And then you can see the arrow for the large Magellanic Cloud and the small Magellanic Cloud that are in their present position, and that they move through there. And I give in the talking points, there is a reference, I believe, I hope, to a movie, a simulation of dark matter in the Milky Way that shows the 3D structure. There's a single still frame of what the dark matter would look like as a result of this study. And if you can show that, Tom, the simulation of dark matter in the Milky Way halo, I think that'll reference a movie.
Oh, there's a moving picture about this, a video?
Yeah.
LMC, Large Magellanic Cloud. And what we just saw looked like a big dark spot blob
Yeah,
behind it.
it, yeah.
Was that the dark matter?
Yeah.
And how do we get to the Milky Way's dark matter if we're looking at our satellite galaxies?
Well, this
How
is
they behave.
Oh, how they behave.
Yeah, by the Large Magellanic Cloud moves through this structure, and because of the way it moves, you can tell the mass distribution that is pulling on it to get that wake or that
Wow.
pattern. And this shows in 3D the dark matter distribution around our galaxy, and you can see that little circle in the middle is our galaxy.
Oh,
See that little
okay.
pink circle? This is a
Wow.
very big structure.
And which part would be the dark matter, the dark blue or the light blue?
Both. That's a density difference. The dark blue is higher density and the light blue is lower density. But they mapped stars in this outer ring as the Magellanic Cloud moved through it. Now, they didn't watch it in real time move, but they know that the wake it produced, this motion produced that wake. And in order to produce that motion, there had to be this big lobe of dark matter off to the side of our galaxy.
Amazing.
So they did a lot of computer modeling. Obviously, a very advanced computer.
Got to tell you, that reminds me of a fetus in the womb. I'm sorry.
It does.
Or passing a gallstone.
2001, it's Odyssey.
Well, just to get rid of my stupid question of the week, as a layman, like most people hear about dark matter, is there dark matter right around us right now? We just can't see it. There's actually little muons or whatever that are invisible.
Yeah.
They'll add weight.
Your voice cut out on my screen when you were asking your question. Could you repeat it?
My question is that the dark matter, if it's here and around us, then it's sitting here in the room with me. We got dark matter in here. Something we can't nail down, can't see.
Correct.
It's invisible
Probably very low
matter.
density.
What?
Probably very low density.
Very low density?
Yeah.
But overall it adds up and adds to the missing, what's the word? I'm like gravitational pull for gravity.
Right now it's believed to only interact through gravity, but there is a paper I read about the core of our galaxy, where there is a sparkling in gamma rays of the center of our galaxy, which it cannot be accounted for, and it's suggested that it might possibly be an interaction indirectly but very closely related to dark matter, because if they assume certain properties of dark matter, they can account for that sparkling of gamma rays, and they can't account for it any other way. There's no other source that would give that. So that's an ongoing situation, and I don't recall any real conclusion yet at the time. But WIMPs, weakly interacting massive particles, are definitely ruled out.
Really? There are no muons, or that would the name
No,
they get?
no WIMPs. No WIMPs.
WIMPs.
Oh,
Yeah.
WIMPs. What are muons? Those are part of the regular matter. Well,
Yeah.
here's a dichotomy that appears to me in our real world, or pro matter, if you will. There's, according to Einstein, matter and energy are the same. That's where you get the E equals MC squared. There's, variations of each, but we're equal. But out there in space, dark matter and dark energy are two totally different things. One's pulling everything together, the other's throwing everything apart, right?
Those are just names, Ron. They don't necessarily have to have a one-to-one correspondence with regular matter and regular energy.
Yeah.
Okay, but
We can call them-
it gets confusing. It's like the matter
Think of
versus
it-
anti. What?
Think of it as more like Tweedledee and Tweedledum. They're two different things, and we don't know what they are.
How do you suppose, is it possible to tell us how they saw what you just showed us, how they found that, they know it's there, how they can make that large blue?
They followed the motions of the galaxies as they orbited. We know what some of the motions were because of the tidal trail. And so you can infer the mass that would cause that tidal trail in that motion.
Bruce,
The observation, if you go back to that still frame, Tom, the observation is the Large Magellanic Cloud wake. It's like a boat going through the lake, and you take a snapshot from an airplane, and you can see the boat, which is the LMC, and you can see the wake of the boat behind it. And so they have that wake, and they had the LMC, and then they can't account for that motion from the mass, the visible mass of the galaxy. So they figure out, they back out of it, what mass would give it this, and mass distribution would produce this path of the LMC around the Milky Way. And that's where they generate that distributed globe structure that you said looks like a fetus.
yeah, all right. And there's a whole bunch of them, about a dozen satellite galaxies, not mentioning Andromeda, that are all closing in on us.
Yeah, there's a lot of little dwarf galaxies that we've sort of stripped of things. They're just little remnant cores and stuff going around it. They're, I think, a dozen or something, these small things. But a lot of them you have to look at through the Milky Way, so they're very hard to pick out.
Right. Ladies and gentlemen, joining us on the bottom of the screen, another beard, stalwart, longtime supporting cast member, Mr. Bruce Murdoch. Welcome aboard. How are you, Bruce?
Yeah, thank you. I'm very good.
You
I'm
wanna
glad
add
to be
anything?
aboard.
You want to add anything to this conversation? Has anything piqued your interest?
No, it's very interesting. I hadn't thought about the wake, and you can use you can do optimization. You can do curve fitting to try to figure out what it is. That's fun to do.
Huh. Okay, and someday they're going to make us a big elliptical galaxy in the few billion years, right? Of all these satellite.
I don't recall which way they go. I think Fritz Zwicky made a guess at galaxy evolution back in the 30s. And I think he started with spheric or elliptical galaxies and ended up with spiral galaxies. But I think that was wrong, and I don't recall what's right.
Okay.
Yeah, but
I don't know the galaxy.
Andromeda is going to become part of us in a couple of billion years, right? So it's going to really distort.
Yeah.
Well, we're going to go right through each other, and
Yeah, Jerry, I think Hubble originally just drew what he called the tuning fork diagram just to like catalog galaxies. I don't think he tried to hook it into an evolution, right?
Okay.
Yeah, I don't think he did.
Okay.
Huh.
That's what I remember.
So it's good. It's good because I didn't follow it. If it's supposed to be evolution, I didn't follow it.
I think they were trying to classify galaxies and they tried to make a tuning fork evolutionary path, but they're finding that it's just not as neat as that.
Right.
okay.
Dark matter got in the way, huh?
Is the theory, before we let this totally go, is the theory about dark matter is that it's just one particle that we can't see, or does it have a whole cast of characters like we do?
We don't know.
Your option, we had a talk on exactly that point
That's true.
when we were meeting in Ferrand Hall before
Right.
COVID, and the guy said that we tend to be looking for one particle right now, but it could be there's a whole periodic table of particles that are contributing, because the only thing that distinguishes dark matter from our matter is that dark matter has no electrical charge. So it has everything else, but apparently, but no electrical charge.
Wow.
We can't interfere, we can't detect it electromagnetically, and that means no light interaction.
Well, do you suppose there's places in the universe that have anti-dark matter around an anti-regular matter universe or a galaxy?
One of the first science fiction novels I ever read was by was called Neutron Star by Larry Niven. And
Okay.
this guy had developed a super hard material, perfect for casting spaceship hulls. And he was going out, and he had a very fast warp drive, and he goes out, and this material is so hard, it just takes everything. And as he's going out there, he realizes the outside of his, he's visiting another star, and he's realizing the outside of his ship is starting to morph. It's starting to change. The antennas are disappearing, they're dissolving, and all this sort of stuff. And he's trying to figure this out. And then he turns his ship around real quick and takes off the other way, because he figures out he's approaching an antimatter star, and he's interacting with the antimatter solar wind of that star.
Wow.
So
Kubrick should have got his hands on that one. That would have made a movie and a half. I always like the science fiction stuff about space elevators. That just fascinates the hell out of me.
oh yeah.
Bruce, we're at the bottom of the hour. Actually, we've got about 15 minutes to go, maybe 20. What's going on with your Theater Organ Society you're president of?
Well, we had the president of Metropolitan Theaters, Dave Corwin, up here, very interested in the organ, and brought a couple of friends about the play. They're going to open the theater on the 22nd of May.
Oh.
They're going to let people come in, walk around. We'll have the organ playing. And then they're going to show an older movie, Ghostbusters 1, at 2:30 p.m. And people will have to sit, rows apart,
right.
Every third row, and then they're like every third seat or whatever. They can't sit close together.
Well, I'll try to get those new dinosaurs that are back at the museum and maybe put them around the edge of the theater. That'd be kind of a nice addition. Taking a quick break.
Our newest CD will be is shipping to me on the 3rd of May, so we'll have it available too. Called "Songs of the Silver Screen."
I know I've asked you this. Do you have an organ at home, a big one with pipes in the
Yes,
wall?
I do.
Okay.
It's an electronic, but it's a con.
So you're like Captain Nemo at Nautilus.
Yeah, it's down.
Like it too. Let's. Any last comments, as Tom has instructed me to remember about what we were just talking about, dark matter and the local group of galaxies? Where is Triangulum? That's even further out than the Magellanic Clouds, or is it the closest one? Triangulum.
Triangulum is kind of the next one out after Andromeda. It's a little farther away than Andromeda.
It is?
Yeah.
Andromeda is closer. I thought it was way out there coming this way.
This is the nebula in Andromeda and Triangulum behind me.
Okay. I'm looking at Tom's graphic on screen.
Mm-hmm.
Okay, we're all coming together though. It's not just Andromeda and Milky Way going to meet. We're all going to.
It's called the local group.
Right.
We're actually getting blue shifts from some of the galaxies in the local group, which means they're moving toward us.
There's somewhere, about a dozen and a half, score of 20 of them, or how many are there? Do you know?
Mm-hmm.
Well,
Tom, you were saying?
How many little in the group? How many mini galaxies, big galaxies? There's two big ones, right? Us, Milky Way and Andromeda. How many of the Magellanic Clouds and Triangulums that are sort of orbiting?
Triangulum's pretty big too. I mean, this isn't counting all the little tiny dwarf galaxies either. So.
Well, Leo 1 and Leo 2 are small.
Yeah.
But
this looks like, a dozen or 20 here.
Let's give Tom a chance to, Tom.
Oh, I'm just going to mention, for me, observing M33 Triangulum Galaxy was pretty tough. Okay. It was pretty tough because it's so spread out. It's a face-on galaxy and it's very spread out. And so I actually didn't see it ever in the Bay Area. It was only down here that I was able to see it. And actually in the Utah desert, you can pretty much see it. You can see it with your eyes, okay? Because it lies opposite Andromeda from the point of view of perspective, okay? It's really beautiful galaxy, but it's very spread out. And so the light is so spread out. It's really tough. It's really tough to see those arms, okay?
Are they all Messier objects?
No.
That is,
No, they don't have an M.
Triangulum and Andromeda are Messier and the rest are not.
yeah.
So we can't see all of them with the naked eye. They're not.
Oh, those are pretty dim.
Gotcha.
Yeah.
Gonna do a plug and then we take the night sky. We got a full moon coming, as you all know. I just want to quickly plug outreach. If your school or organization would like to schedule a virtual outreach involving an online demonstration of some sort using Zoom, lots of graphics and photos till we can get back to going outdoors at night, contact our outreach coordinator on screen there, Chuck McPartland, outreach@sbau.org. So we do the night sky, gentlemen.
Sure.
Oh, there's the moon. That would be on which night of the week? Tuesday? Moon is in perigee. It'll be full and it'll be closest to the Earth about 8:22 in the morning. It's in Libra. We got a few very few shadows. So you guys aren't crazy about a full moon, right? With your telescope.
Right.
Nope.
I like them.
No shadows at all. You can't see any shadows at all when it's full. Just bright. And Tranquility and Serenity. There's all these other seas. Bright, Sea of Serenity, Sea of Tranquility. Are they all named for nice, friendly, relaxing names like Tranquility and Serenity?
No, there's Ocean of Storms and
Yeah.
But somewhere on Tranquility is Apollo 11. What's left?
it's right in the upper arm of the soccer player there.
Yeah. Or the rabbit.
This type of scene with the full moon always reminds me of a peeled orange.
Yeah. I
The
was just
lines
gonna,
going-
I was just going to mention too. I mean, I like the full moon through binoculars because you can see all the splashing rays on it. You see the ray structure, all the splash of dust. If you look to the far right on this photo of the moon, that's Mare Crisium, the Sea of Crises, and you see that little splash to the left of it.
Mhm.
That's right on the edge of the sea. I believe it's called Proclus. Okay. It's really great. You can see these ray structures beautifully. So that's a neat thing about a full moon.
Huh.
Other than it destroying this dark sky.
Yeah.
Well,
There's a kind of a dark sky event tonight too, in that Mars is going to be in the feet of Gemini, and it's going to be in M35 in a big open cluster.
Oh.
So it'll be a great telescopic view
Yeah.
What time?
tonight.
Right, yeah. It's not,
It's
gonna
not
be-
like Mars is moving that fast.
Right. Yeah. Now Cerberon is outshining Mars.
Yeah.
I've just been seeing that. Yeah.
Mars is in two big stories. Then one is the Perseverance on the screen, and we're just getting radio waves on that. The other is way out there. It's not close. We beat it, didn't we, by a half an orbit because we're in closer. That's how that works. Shall we run through the week real quickly as far as night sky, gentlemen?
Well, one more thing today is there may be a launch at 1:46 from Vandenberg that will be
Oh.
very, very worth watching if it goes off. But
Oh, yeah.
if you want to see that whether it's happening or not, because they have to worry about high altitude winds, go to spaceflightnow.com.
And that'll be a military surveillance again, right?
It's a national reconnaissance office.
Okay, and that's not one of Elon Musk. This is the old Delta.
It's a Delta IV Heavy, so it should be pretty spectacular.
That the
Wow.
one?
Space flight today, you said?
Spaceflightnow.com.
Oh, now, okay.
And
There it is.
someone said 11 a.m., not 1:30. What was Tom talking-
1:46 p.m.
Yeah.
Yeah.
1:46 in the afternoon.
Mm-hmm. Mm-hmm.
Normally they launch those things in the middle of the night for some reason. It's a change. Okay, we'll be on top of that. Give you a report next week. The flight on Mars is done, but the Monday sky shows Jupiter in Aquarius near Capricornus. Did we talk about this already? I think we did. Didn't we?
That's morning. That's
Yeah.
morning.
That was this morning. Yeah.
Jupiter is really bright in the morning too, but it's like 3 a.m.
Yep.
Okay, and including the 4 big moons, you can see those too, right?
Yeah,
30.
Galilean moons. Yeah.
Shall we go to Wednesday? Can't read my own writing, just barely see it here. Tiny, the word I wrote. The planet Pluto.
Oh, good luck.
This is in the Wednesday.
Magnitude.
Yeah, okay. Stationary against, why can't I read? It's the stars at
Yeah,
midnight.
Sagittarius.
I don't think any of you guys are up with your telescopes trying to find Pluto, are you?
Well, I've
Nope.
looked for it before. I get it by imaging.
I saw it in Tucson in the 61-incher.
It's pretty dim. That's cheating.
It's pretty dim.
Okay.
And I've seen it in my scopes, but it just looks like a dim star. You can't
Yeah.
see
It
much.
occulted a star a couple of years back, and so I was recording it, and you could actually detect Pluto's atmosphere in the light curve.
Ah,
Really? Does it ever, it crosses the orbit of Neptune, doesn't it?
Yes.
yeah, it does
Mhm.
inside Neptune, but not in plane.
But not what?
It's tilted. Its orbit is tilted.
Well, I
Yes.
understand that, but is it possible to track that? Say, hey, it's going through Neptune's orbit, and they don't ever get real close, do they?
Right.
Obviously, Pluto's going a lot slower, whatever.
So, but anyway, as the star chart that Tom had up there showed the region where you can find Pluto, it also has, Pluto is near M75, which to me is one of the most spectacular globular star clusters in the sky. And we have a picture of that down below the star chart.
Mhm.
Speaking
If
of,
I might pick a favorite, Jerry, M22.
There. That's a spectacular, that's my background shot on my iPhone.
Oh my gosh.
Spectacular.
did
Yeah,
Messier
that's
ever
Hubble.
go?
And you
Did
can-
Messier use a telescope for any of this,
Sure.
or just see things in the sky? I suppose.
No, he had a 3-inch refractor.
Oh, is that
Mhm.
right?
What's that?
Messier.
Charles Messier.
There's
I don't know what
somebody,
size it did. It wasn't very big.
and science has latched onto those numbers, and the 78 of them or something, right?
Not so much science. Those are more popular, amateur astronomy things.
Yeah.
They do look at things coincidentally, because M87 is the one that has that black hole in it that we got a picture of.
Oh,
Yeah.
But they're just in the mix of everything.
And
But
it's
you can
110 objects run.
Yeah.
Yeah.
Or 109, depending on who you talk to. You can see some really nice, the color is really nice in these stars.
Oh, beautiful.
Red
Yeah.
giants.
but
And,
the M87 is a galaxy, right?
M87 is a galaxy.
Yeah, that's in Virgo, though.
But this is M75, a globular star cluster.
And you shot this, Jerry?
No, this is not my picture.
I was going to say, it looks like a Hubble
Oh,
shot.
no, this is a
Yeah, it
Hubble
looks like
picture, I
Hubble.
think. This is the one I have on my iPhone as a
I
background.
got it. Okay.
I stole it. So, and then as Tom pointed out just a minute ago, there's a really nice blue-white star off to the left of center.
I love that little line of stars at about 3 o'clock too.
Isn't that cute? Yeah.
The little inchworm of stars.
Yeah, like Alley's braid, huh?
Yeah.
We found an asterism right there, the inchworm asterism.
Yeah.
That's a galaxy we're looking at. It's not
It's
rotating.
not a galaxy. It's a globular cluster.
Oh, it's
Yes.
part of our galaxy. Okay, got it.
These things, it rotates around our galaxy, but not in the plane of our galaxy.
Oh, so this is a satellite galaxy.
But it's not
Sort
a
of.
galaxy.
Well,
It has-
no.
Yeah, go ahead.
Oh, I
Globular.
was going to say it's a cluster in our galaxy, and like Jerry said, it's off the plane, and
Okay.
it was these clusters that basically gave us an idea how big the galaxy actually was. How far it extended. And Ron, if you were confused about Corona Borealis,
Right?
you see on the lower area there, Corona Australis. That's
Right.
a beautiful little crown. No, southern crown, right? Southern crown. It's really pretty. In a dark sky, it's easy to see with your eyes, that little crown.
Really?
Oh, yeah, very easy to see. It's right under Sagittarius, right under the teapot.
And that's part of, we're looking at a globular cluster, the main stars in it.
These
No.
The circles with the cross in them are globular clusters.
Right.
But if our solar system was in a globular cluster, there'd be no night, would there?
No,
That would be real dark.
Wouldn't be real dark. You'd have a problem that made the LED streetlights in Galita look like nothing, wouldn't you?
there are probably no people inside of a globular cluster because it's not clear that a star can hang on to its planets in that kind of density. They may be swapping planets at different times.
Really?
Yeah, speculated. Now this one, looking at Sagittarius like this, we're looking just above M22 in that region and Caus Media. We're looking at the center of our galaxy.
Mm-hmm.
This is a very target-rich area to just point the scope up there, and it's going to be very rich in stars and nebula. Several famous nebula are up there. What is that one? M8. What's that one called?
Yeah, the Swan.
Lagoon.
The Swan.
Lagoon.
The lagoon, yeah.
Lagoon.
Yeah.
Trifid, the Eagle,
Trifid Nebula.
the Swan.
That's Tim Crawford just loves those.
And M11 at the very top is what's that? The Flying Duck Cluster or something?
The
Yeah.
Wild Ducks.
Wild Duck. So it's an open cluster of stars.
Those lines.
You have to have a good imagination to see the flying duck cluster, though.
Oh no, it has the shape of a V. I can see them, flying through the sky.
Okay, that's what I was supposed to look for. Okay.
Yeah, a V. It's like a V. Mhm.
It really should
Okay.
be called the Flying Ducks Cluster.
Flying duck. Is that another asterism?
Yeah.
It is.
Yeah,
That's
you were
all
going to ask about the lines. Those are separating borders of constellations.
Right?
So M11's an open cluster, Ron. Okay.
Oh,
And the things with the little crosses in them are globular clusters.
wow.
Okay. Which tend
Oh,
to
it's
have
the
very-
wild
very
duck cluster, not the
old stuff.
flying duck.
Yeah, the Wild Ducks.
Wild ducks. Yeah.
So much stuff up there.
Yeah. Oh, yeah.
I do have an announcement, if you don't mind. This was on your talking points, Mr. President. Now on our SBAU Facebook site
Yeah.
is NASA and ESA, which is the European Space. Anybody want to talk about that? The map that's out?
We did that.
What's it show? We did that outer reach. Oh, that was the picture we had earlier. I remember the Milky.
Yeah.
That dark matter is not mentioned in this. That's why I went to that. Images of the Milky Way and large Magellanic clouds. All right, that's the rest of my stuff. We're down to the wire. We missed certain people. Got our wives behind us. At least you guys do. And we're waiting to, now that we've all been vaccinated, to get together and have a Friday night meeting, and a week later have our incredible, there's a cat.
Flying through.
Yeah. Bruce, once again, where is that organ recital going to be so we can all come?
The 22nd of May, Saturday.
Oh,
Going to start at the theater will open at 1 p.m. The movie will be at 2:30, and our staff organist Adam Macedo will play from 1 to 2 p.m. He'll play light music, the stuff that you play in a theater pipe organ. That
yeah.
it isn't going to sound like a church pipe organ.
Do you suppose they're going to do it like restaurants, a quarter capacity of the Arlington? You sit 10 seats away from everybody, and every other row is.
Yeah, well, I talked to the manager about what they're going to do. No, they're going to seat people every third row and every fourth seat or something like that. So they're more than 6 feet apart.
Okay. And Tom Whittemore, you're having a bake sale on the side of the street, I'm sure.
I actually baked 2 ryes this morning.
Did you rise?
Well, I love rye. Yeah.
Is
I
that
love rye.
sourdough? Because man, that's
Oh yeah, it's all sourdough, Ron.
you
yeah.
would do incredibly well on the side of the street selling that stuff, except the health department would come and nail you. Gentlemen, we've run out of time. Tom Totten, you're awesome. Thank you, my friend. We'll be in touch, and we can all see this on YouTube, right? Replayed, it's archived. SBAU.org. Go there, join us. We'd like to have a huge crowd by the end of the year. So Jerry, the 2 Toms, Bruce, and Chuck, thank you very much. We'll see you next week at 11 a.m. on Monday morning for number 10.
All right. Thank you, Ron.
Ron. Thanks,
That's great.
Tom.
Everybody
Thanks very